And indeed, bringing quantum computing into application is a task that neither politics or academia or industry can accomplish alone. And to succeed, we do need a joint effort. And to add the industry's perspective into this equation, I'm happy to welcome today Dr. Melanie Maas-Brunner. She's a member of Executive Directors and Chief Technology Officer of BASF. BASF is a German multinational chemical company and largest chemical producer in the world. And Dr. Melanie Maas-Brunner holds a PhD degree in chemistry, and before she joined BASF, she worked as a research assistant in Germany and in Canada. It's a pleasure to have you here today. The floor is yours, Dr. Melanie Maas-Brunner.
So, sorry, I couldn't unmute myself, so should work now. Thanks a lot for this very kind introduction. And I think good afternoon, ladies and gentlemen. It's really a pleasure to participate in this Bitcoms Quantum Summit. And as you heard, obviously my task is to share some insights from the perspective of the chemical industry with you, specifically from the BASF perspective. And as you heard, I'm only a chemist and surely not a quantum computing specialist. So just in case I say something which is really stupid. So, but nevertheless, as a chemist, I'm completely convinced quantum computing will fundamentally change the industry and especially the chemical industry. It will make us better, it will make us faster and also more sustainable. And it will also be a key technology for our future innovations. Let me click. I can't click. I don't know how I do this now with the clicking. Question here. Thanks. You might know that at BASF, we create chemistry for a sustainable future. And sustainability and innovation are really part of our DNA. Our products and innovations help solve some of the biggest challenges of our time. Just think about battery materials for electromobility. Think about insulation materials to make housing more energy efficient. Or think about chemicals that make wind parks more durable. We support our customers in nearly all sectors in almost every country in the world. And we all know in silico experiments have proved to make product development in the chemical industry more efficient and effective over the past decades. But the challenges are growing and because they are becoming more and more complex. And this is why quantum computing will really provide a true quantum leap for us. Quantum computing will disruptively change the development of chemical products and their formulations. It will make the modeling of chemical reactions, properties of molecules, and also process parameters for an optimal formulation much more precise and much faster. Simply said, I think quantum computing will help us develop better products for our customers in an even shorter time. So let me give you a concrete example from our research. I'm not sure why I can't click this. Yeah, that's it. So you might know that from chemistry class that catalysts are the accelerators for chemical reactions. And you see here some examples. They help carry out reactions at lower temperatures and under lower pressure. And this all saves, for example, energy. We at BASF use catalysts in more than 80% of our own production facilities. And we accelerate with them and we control reactions. New catalysts with new properties are extremely difficult to predict and subject of intensive research in our labs. And in the past 20 years, quantum chemical modeling technology has made really great progress. And it's nowadays an important contributor to catalysis development. But however, we are far from designing catalysts from scratch with quantum chemistry. Why is that? One reason is that catalysts are complex systems and we cannot even set up comprehensive models for them. However, there's a step where the catalyst creates and or destroys one or several chemical bonds. And this is the step that can be described by quantum mechanics only. This moment of bond creation or breaking is at the heart of catalytic activity. And quantum computers can really accelerate the computation of this very moment of bond breaking and formation. So right now we already work on that with classical supercomputers. However, there is a limited accuracy here. So the quantum computers will provide improved methods with affordable computational effort. And we expect that first working quantum computers will act like a math coprocessor. And exactly this is the reason why we at BASF are focusing on developing a hybrid approach, classic computers and quantum computers that are working hand in hand. Time-critical parts of the code are accelerated by the intrinsic parallelism of the quantum computer. And in the best case, we expect an exponential speed up here. An improved simulation based on quantum computing can not only accelerate chemical product innovation, they are also key on our industry's journey towards climate neutrality. So why is that? At BASF, we have set ourselves very ambitious climate targets. By 2030, we want to reduce our CO2 emissions by 25% compared with 2018. And of course, we aim to achieve net zero emissions at a certain point in time. These targets are very ambitious, and chemical production is by nature very energy and CO2 intensive. And the key here lies in rethinking and reworking chemical production processes and their technologies. And therefore, we ask ourselves the question, in an already highly optimized Verbund structure or production structure, how can we produce using less energy? How can we substitute certain raw materials while keeping the exact same product quality? And can we adapt production processes to reduce our carbon footprint? How can we optimize logistics to bring our products to our customers even more efficiently? And all those answers, they could be provided via quantum computing-based simulations, only by them. Simulations that can also take into account the enormous complexity of a highly integrated chemical Verbund like our headquarters here in Ludwigshafen. And here, these are just a few examples of a huge number of applications. Whenever there's a problem and it has exponentially increasing numbers of possible solutions, the quantum computers offer advantages. In other words, we take weeks or even longer today, and it can be done in minutes just by having this very great solution. I think quantum computers for industrial use will probably only be available, let's say, in 5 to 10 years. So what does it mean for us? The chemical industry, as an early adopter, will primarily be a user of this technology. I think we won't build quantum computers ourselves, most likely not. But we do need access to quantum computers today in order to be able to develop algorithms and applications to train our experts how they have to work with this new technology. And the application must be developed in parallel with the development of hardware, so that we can really take advantage of the enormous benefits of quantum computing as soon as it is available. So how do we approach this? I think we need to rely on partnerships and cooperations. Cooperations between hardware and software developers, and their science and politics and industry. And that's why we have established a research partnership around the globe to develop quantum computing algorithms for industrial applications. There is, for example, something that we do with the startup HQS from Germany, Zapata, Google Quantum AI, and the Fraunhofer Gesellschaft. That's just to name a few of them. We are really convinced that we need to join forces across industries in Germany and in Europe in order to be able to pick up the pace that China and the United States are really implementing here. I think they are already way further advanced. The establishment of the quantum technology and the application consortium QTech, together with 9 other leading German companies last year, and I think there already have been 2 newly parties joining here at the beginning of this year. This was really an important step and part of the quantum computing roadmap published by the German government in early 2021. And it's now really crucial that industry and politics continue working together, focusing on the further implementation of the roadmap. We need to work together. We need to create synergies from it, and we have to leverage resources, financial resources, and of course also human resources. And to develop the technology at the necessary speed, that's really important. We need to work together across Europe as well. The European Quantum Industry Consortium is a great example for that. I'm really convinced we can only achieve our goals together. Our involvement in the BMBF-funded project Quantum Computing User Network is driven by this idea. Here, together with the Ludwig-Maximilians University Munich, SAP, and the startup Aquarius, we are working on the creation of network and ecosystems for German quantum computing users, and with this offering easy access to this technology. So as we look into the exciting future of quantum computing, we have 2 major tasks ahead of us. I think on the one hand, we must create the necessary conditions in Germany and Europe to be able to build quantum computers at all. And on the other hand, we also must be able to use them profitably and start developing the corresponding applications together. We need to act now if we want to make use of the technology in the near future. And we should also not forget about the area of talent development and education. The technology will mature, and the demand for trained experts will increase really sharply. Experts who can not only program, but also model the challenges so that we can solve them with the quantum computing solutions. Therefore, we participate in a training network funded by the European Union. This is another great example of the importance of collaborations across politics, academia, and industry. So, ladies and gentlemen, I think you all know and you feel the same. The world is becoming more and more complex. And to solve these complex future challenges, we need to work together. So this is really my pledge. We need the enthusiasm, creativity, and the strong will to go forward from all of you. Innovations from chemistry will play a key role. And we at BASF are really going forward towards a more sustainable future. And this is why we also want to be part in shaping the future of quantum computing. I strongly believe that by working together, we can achieve this necessary quantum leaps. So thanks a lot for your attention, and I wish all of you a very exciting and successful summit. Enjoy it.
Thank you very much, Dr. Maas-Brunner. That's really exciting, the future in quantum computing that awaits us. And as you rightfully mentioned, we do need to start developing applications already today, as early as possible. And for that, we do need an access to technology and access to platforms. And in this scenario, the combination of high-performance computing and quantum computing here can offer a really good opportunity to start with this technology.